Hi everybody, welcome back to our discussion on how to use the present value tables to calculate the issue price of a bond. As discussed in the prior video, there are 4 steps necessary to calculate the issue price of a bond payable. 2 of those steps require you to refer to present value tables. Your textbook includes a set of present value tables. We will look at the present value table B1, located in Appendix B at the back of your textbook, and we'll also look at the present value of an annuity table, Table B3, located in Appendix B at the back of your textbook. Before we begin to practice, you will need to understand how to use these present value tables and which table you should use. So let's look at them carefully and see how they work. These tables are built on the assumption that money grows over time because it earns interest. Let's look closely at Table B1 on page B10 of Appendix B, located in the back of your textbook. Table B1 is the present value of 1. The present value of one lump sum. It is used to calculate the present value of any single amount. Read the periods, number of periods, column down. Find the appropriate period, your semi-annual number of periods for your bond payable. Once you find that number of periods, N equals number of periods, then read the table across in that row until you find the appropriate interest rate column. At the intersection of the row and the column, you will find a factor. You will multiply that factor times the par value of the bond to calculate the present value of the bond's par value. Now let's look at Table B3. We're going to skip over the future value table. They're not necessary for us in this chapter. And go to Table B3, which is the present value of an annuity of 1. It's on page B11, located in Appendix B at the back of your textbook. This table is used to calculate the present value of any series of equal payments made at the end of each compounding period. It works very much the same way as the present value of 1 table. You find the number of periods in your semi-annual interest periods in your bond. When you find the number of periods, then read across till you find the appropriate interest rate. Use that factor times 1 interest payment, and that will give you the present value of the entire series of interest payments. Let's practice with example 1 on your worksheet. Example 1 is already completed for you. Let's see how it works. We have a 5-year bond. Interest is paid semi-annually. 5 times twice a year is 10 semi-annual periods. So N equals 10. The number of periods equals 10. The par value of the bond is $400,000. The contract rate of interest is 12%. That 12% is an annual rate, so 1/2 of that rate is used to calculate the semi-annual interest payment. And the market rate is 10%. 1/2 of the market rate of interest then is 5%. So when we are looking at the present value tables, we're looking for N equals 10 payments, I equals 5%, because we always use the market rate of interest when we're calculating our present value using the present value tables for the bond. Let's work through this. Step 1, calculate one semi-annual interest payment by taking par value of the bond times 1/2 of the contract interest rate. $400,000 times 1/2 of the contract interest rate, 6%, equals $24,000. Step 2, calculate the present value of the bond's par value by multiplying the par value of the bond times the present value factor from B1, table B1. It's done here for you. Let's look at it, then we'll find this factor. Par value of $400,000 times a factor of 0.6139, the present value of $400,000, where N equals 10 and I equals 5%, is $245,560. Now let's find this factor. N equals 10. Read that row over till we get to the 5% column, and the factor for the present value of one lump sum off of table B1 is 0.6139. So again, the $400,000 par value times that factor equals the present value of $400,000, where N equals 10 and I equals 5%. Step 3, calculate the present value of the stream of interest payments by multiplying one semi-annual interest payment times the present value of an annuity factor found in table B3 at the back of the textbook. It's already done for you. Let's go over it and then we'll find the factor. The reason we did step 1 is to calculate one interest payment so that we could do step 3. So one interest payment of $24,000 times a factor of 7.7217 equals $185,321. That's the present value of the stream of 10 interest payments at a rate of 5%. Let's find this factor where N equals 10 and I equals 5%. Looking at table B3. Table B3, located on page B11 in Appendix B at the back of your textbook. Table B3 is the present value of an annuity, where N equals 10. Read that column over, that row over, till you get to the 5% column. And that factor at the intersection of row 10, column 5%, is 7.7217. And that's where this factor came from. Step 3, multiply one interest payment times the factor, present value of an annuity factor, where N equals 10, I equals 5%, So the present value of this stream of $24,000 payments equals $185,321. Step 4, add the two present values together, and that will calculate the bond issue price. $245,560 plus $185,321 equals $430,881. So the calculated bond issue price is $430,881. Well, that's all for this video. When we come back with the last of the 3 videos on calculating bond issue price, we will work example number 2 together, and then I will have you work example number 3 and check your work. See you next time.